Making my first video tutorial on physical science material of 10th class, chapter called electric current. Today, firstly, what is electric current? We are going to discuss about a topic called as electric current. We'll learn what is electric current first. So you might have seen in many situations that we either say electric current has gone or electric current has come. This is our electricity bill. So what actually electric current means? So here electric current is a source of energy firstly. It is related to electrons, as electric current means it has some word called electrons in it, right? Electric means it's related to electrons. So we know very well electrons are the negatively charged particles which are present in any material. Every material, irrespective of its state, has electrons in it because matter is made up of three states. They are solid, liquids and gases, and every matter, that is every substance, either solid or liquid or gas, have electrons, protons and neutrons in them. But protons and neutrons are the particles which are present in the center of the atom, and they never show any movement, whereas electrons are responsible for the formation of bonds, for the formation of substances which result form the compounds. So here even electricity is because of electrons. The electrons which are present in the compound, they simultaneously move forward, and this movement of electrons in a particular direction is termed as electric current or electricity. So before going to the further chapter, we need to discuss regarding what is Lorentz and Drude's theory regarding electric current. So this is the first topic we have in SSC book, Lorentz and Drude's theory. When a conductor is set free, conductor in the sense an object which possesses an ability to allow the electrons to flow through it. Any object, any material which allows the electricity to pass through it can be termed as conductor. Now this conductor can be a metal like iron, copper, silver or zinc or any metal, or it can be a liquid like salt water and dilute acids or mixed water, impure water. So this conductor, any conductor, especially if it is a solid conductor, it has electrons in it, because a conductor, solid conductor, is made up of millions of atoms, and these millions of atoms have millions of electrons in them. These electrons, which are in millions in number, will not stay stable in the conductor. They continuously keep on moving, but there is no specific direction. As you consider an insulator, even they have the electrons which continuously move. So we are going to discuss regarding what is Lorentz and Drude's theory for conductors. Conductors, when they are set free, the electrons in the conductors keep on moving irrespective of their direction. They have different speeds, different directions, and sometimes they collide with each other when it is set free. But what happens when you connect a battery to the conductor is a question. When you connect a battery to the conductor, the electrons which are present in the conductor are attracted by a force that is electrostatic force. An electric field is set up in the conductor which is responsible for the movement of electrons. When we connect a conductor to the two terminals of a battery, the conductor has some electrons, and these electrons move towards the positive charge of the battery. Not only one electron, all the electrons, they will move towards the positive terminal of the battery, making a flow of electrons. So if it was set free, then electrons will be jumbling inside the conductor. That means they don't have a specific direction to move either forward or backwards or up or down, left or right. Some of the electrons move forward when it is not connected to a battery, and some of them move backwards. But if you consider any point over the area of cross section over the conductor, then number of electrons moving from right to left will be always equal to number of electrons passing from left to right when the conductor is set free. But when the conductor is connected with the battery, the electrons which are moving from one direction to another will never be equal to the electrons which are moving from another side to backwards. Like if electrons moving from forward to backward are not equal to the electron moving from backward to forward, because there is only one direction flow of electron. That is why we call electric current is flowing. And always remember that when electrons are flowing from negative to positive terminal in a conductor, then electricity is flowing in positive to negative terminal of the conductor. That means when electrons flow is in forward direction, that is the electric current is in backward direction. The direction of electric current is always opposite to the direction of flow of electrons. This is regarding the Lorentz zone, Drude's theory. The next thing is, how can we formulate electric current? So here we know electrons are a type of charge and we denote the charge by letter Q. If Q is the charge and its units are coulombs. If one electron has some charge, that means two electrons will be having 2 into that charge. And if n number of electrons are there, they will be having n into charge of electrons. This charge of electrons is in coulombs, and if 1 coulomb of charge is passing through any area in 1 second, then we say that 1 ampere of current is flowing through the conductor. That means if you want to formulate the current in terms of coulombs, and that is charge and time, current can be given as I is equals to Q by T, where Q is the charge and T is the time taken. If I is equals to Q by T, that means 1 ampere is equals to 1 coulomb per 1 second. This is the formulation of electric current. Now we will discuss regarding what is voltage. You might have noticed that several people speak regarding voltage in our houses. In many of the electronic devices, there is a rating or there is a description given. This device will run only in this particular voltage. So what do you mean by voltage? Normally everybody thinks that voltage is similar to that of electric current, but it's completely wrong. Voltage is completely different from electric current. So we already discussed regarding electric current. Now we will discuss regarding what is voltage. Voltage is also called as potential difference. Now if you consider a conductor, in that conductor of length L, in that conductor will be having some electrons in it. So when battery is connected, 2 terminals of battery are connected to the conductor, the electrons in the conductor flow from one direction to positive terminal of the battery. That means some electric field is set up in the conductor. That is why the electrons are moving in unidirection. That electric field, electric force is doing some work to move the electron from one end of the conductor to another end of the conductor, because we cannot simply move the electrons. There must be some work done to move the electrons, and that work done by electric force to move the electrons from one end of the conductor to another end of the conductor is termed as potential difference. And potential difference is also called as voltage. As it can be measured with the device called as voltmeter, and its units are volts. In the coming video, we will discuss regarding the resistance, EMF, and different laws like Ohm's law and Kirchhoff's laws of junction and loop, and we will discuss regarding the electric power. Until then, don't forget to subscribe my channel. If you like this video, please click the bell icon and subscribe my channel. Thank you very much for watching my video. Keep watching my video. This is Amar.